Starting the recording. This is the study guide. We just finished the chapter 1, and as you can see, all chapters until chapter 11, then we'll start the content will start more heavier, more in depth than compared with the 10 chapters before. You can see most of the questions I will put, and as I said, I contact the department, and I was told this is up to the instructor. They did not decide about the standardized exam yet, not like chemistry. The problem in this, because they are not united through the whole campuses, even including downtown, about the textbook. So we have different textbooks being used in all campuses, including our 5 campuses, including downtown campus. So I think that's part of the issue they have. So they cannot really have a standardized exam like chemistry, because every campus uses, I think, their own textbook. And it's opposite to chemistry. We are using, even including downtown, the same textbooks. In all undergraduate textbooks, we're using the same thing. So no different textbooks. So that makes easier to have what standardized exam, because we are in the same wavelength. So with all the other campuses, but the environmental science, this class here, each campus, I think they are using their own textbook, and therefore it's very hard to have standardized exam while different textbooks being taught by different instructors at different campuses. So that's hard. So my final exam will be based on I'll put the final exam. I could not make it this because I am busy with the lab exams in chemistry, so I finished all those finals. They are ready to go. I'll finish yours by, I think, Friday or Saturday. Coming Friday or Saturday, I'll finish your final exam, and then our review will be more concentrated on those questions rather than going through all this longer study guide, which is really very comprehensive, and it will take forever to really review. If you look at the study guide here, as I said, chapter 16 is not included. The last chapter is chapter 15, is the last chapter. I followed my friends, the other professors in all campuses here. They don't include chapter 16. It's more or less is political science class, so they did not really include it in the final exam. But anyway, we have taken that, we cover it, but it's not part of the final exam. So we'll go today chapter 2 as we go, but then the exam will be, everybody knows when the exam is? Everybody knows? Somebody told me, and then I think I put, yes, 30th, yes. I put the schedule somewhere. Did I put the schedule somewhere? I think. Yes, that's the final exam here. The final exam goes by the time, by the way, so it goes by the time. So time is, we are meeting 11:30, so this is the time we are meeting here is here, between 11, which is really here. It goes by time. And then because of the time, we will be 11:30. So 11:30, this is Monday, Wednesday, 11. It goes by time. Not even by, you have not to look even at the dates. Look at the time when is your class starts. That will be your final exam. All your classes, look at the start of your class. So it starts 11:30. That will be Monday, Wednesday, 11:30, and then we'll give you the exact day. This is Wednesday, the April 30th, from 11:30 to 2 p.m. Since we are using just 25 questions, as in chemistry labs, so that's what I give them. And chemistry is different. So some higher chemistry, we are using 70 questions in 2 hours. But this one here, maybe 90 minutes, 1.5 hour in 25 questions. That's, I think, will be more than fair, I guess. So what do you think? 90 minutes will be good for 25 questions? I think you'll have enough time. Now, 1.5 hour, that's more than enough for 25. In chemistry, higher chemistry, that's a little bit difficult because it's a lot of math calculations. They have 70 questions in 2 hours, but still 2 hours is not enough to finish calculation-based questions. They take longer time to do and longer time to review. But anyway, we'll meet here for the final exam. But meantime, this Friday, I promise you, I could not make it because I was busy with the labs. I have a bunch of labs, two labs I have, lower chemistry one and higher chemistry one. I was looking at their finals, revising the whole finals, and then, so now it's your turn will be Friday so you can expect by Saturday or Sunday. So I put really a real study guide, not the whole thing here, what I put. The one that I put here is just more comprehensive, which covers most of the stuff here. So what I put here is mostly, as you can see, all these chapters here. After chapter 11, you will see that then things will be more comprehensive. 11, 12, 13, those are more stuff covered. 14, 13. So, but anyway, so I will give you the extracted or summary study guide of the real one, which is really reflecting the real final exam. Not the same, no, not the same, but at least you can expect what you can expect, those type of question, and everything will be based on definitions. So prepare for yourself to memorize a lot of definitions, and it has to be not exact. The main thing is it will be multiple choices, and then for multiple choices, you can answer the correct answer. So you don't have really to memorize all the what they call it, not all the definitions, but at least you understand what this definition is all about. When you get four multiple choices from A to D or 5 from A to E, then you know which one is very close to the correct answer. Agreed? So just pay attention for the class by Friday or Saturday. I think by Saturday, because by then I have to conclude all the chemistry stuff out of my way. As I said, we have labs coming next week, our finals in chemistry next week. How about your final next week?
No, it's
Oh, the 28th. No, in chemistry we have 1 week before. We give our students 1 week so they can recover the whole labs and then have 1 week more in advance to prepare for the final in the lecture. The lectures are standardized exams and they are really connected to time, and the problems of our finals in chemistry is the time. It's not the content itself, but the time. So they, that's like the same thing if you take the nursing exam or taking undergraduate exam, GRE, GMAT, all those standardized exams. The content is not difficult, but there is not enough time to finish them on time. So you have to be trained how to answer those questions. But we'll go for chapter 2 today, and we'll look at chapter 2. And please read the announcement of the extra credit. If you want to submit any extra credit, the extra credit should be submitted before the final. Any submission after the final, even if you submit them, they will be not graded, not accepted. So any outstanding stuff has to be done before the exam. I cannot open any quizzes after the final exam. This is a policy of the university and we have to adhere to it. After final exam means the class is over. There will be nothing, except there is an emergency, death in the family, car accident, whatever, that's a different story. You have to provide documentation. So if I ask by the university, I have documentation to give the administration. So anyway, so if you have any outstanding quizzes, please email me on time. I have a lot of students are asking and reopen those, but everything has to be before the final. After the final, don't ask me anything. I can't do nothing for you. It's a policy we have to adhere through all these years. After the final exam, the class is over. I will keep it open for you. I'll keep it for at least 2 or 3 weeks open, sometimes 4 weeks, 1 month, and then I have to shut it down, deactivate it, so you'll not see it there. So you'll have plenty of 4 weeks to look any material you want to see or anything. Applying for, I don't know what they will give me, might give me the second sequence or the first or none, depending on what they will give me. So I might not teach the second one. I might not teach even the first one. I go with the flow. Whatever they wanted from me, I just do it. Okay, guys. So let's go for the chapter 2. Anything about the chapter 1? Anything about chapter 1? Or any chapter you have in reference? As I said, it will be just mostly definition. Because the whole book, if you look at the whole chapters, it's really definition based. It's not really critical or something. And I checked with other professors; they don't do case study. So so it is. Or let's make it the chapter 2. You want chapter 2? What chapter you like? Any chapter in preference? Any chapter except chapter 16. Do you have any chapter in preference? No? I will make chapter because those chapters were the quizzes, they were very difficult written. So let's take chapter 2 and see. And then by if I have time, I can start it, but so busy with those labs. Those labs takes a lot of time. As a matter of fact, they take more than lecture because the lab we have in chemistry 2 sections of the lab exams. One is a written and one is practical at the same time. So 2 hours, part of it for written, part of practical. So I give the students something they know on one of the experiment, and then tell them to perform quickly this experiment and get the data from that experiment. So okay, guys, so it is. As I said, we don't take any case study. System interaction, those are the same thing, and you have seen quiz 2. It was not, I did not use it, and we just canceled those quizzes. I gave you credit for those 1 and 2 and 3. The quizzes from the textbook was written in a way that's really is not understood. So if you look at the study guide of this, is one ecosystem that will come, because this ecosystem definition will go through different chapters. Not only one chapter or 2 will cover a couple chapters. So it is, just get this one here. As I said, chapter 1 to chapter 10, those are very, it's not condensed. So that's chapter 2. As you can see, chapter 2, the first thing is an ecosystem. So I can divide this one here in 2. And so I divide those. I divide the screen into sub-screens. So here we are, we have number 2. And number 2 is here in the top. Let me take this one here out here. So number 2 is ecosystem definition. Look at this. We did this chapter 2?
We start at atom structure.
Oh, chapter 2, okay. Good. Any question about atomic mass, atomic number? Any question you have? I know that's chemistry, but any question you have about this? Well, we stopped on this. Then let's finish one topic there, and the topic called isotope. Somebody will tell me what the isotope is? Is it in the book? I think it's inside, correct? Let me see. So structure the so here it is, atomic mass isotope. So let's define what isotopes are. Somebody will tell me what isotopes are? Any clue? Yes. Okay, let's look at examples. So you can get the isotope. It's a modification of each element found in nature that has a different type of modification. An element has in nature different, according to the abundances of these modifications, will have different type of modification. We call those modifications are isotope. So isotope of carbon, for example, carbon has a symbol of capital C. Now, the way we write the isotope, the symbol capital hyphen or dash, and then we put the atomic mass of that isotope. So carbon has carbon 12, and we have carbon 13, atomic mass 13, and we have carbon 14. So carbon 13, about abundance in nature, about 1%, and 99% is 12. That's close to 0% or less than 0, something 0, something 1%, something like this. So we ignore it. So very, very close to 0. So with this, their natural abundance, but the same. So carbon itself found in nature in 3 types of modifications, correct? Meaning different atomic with different atomic masses. Different atomic masses means the number of neutrons in each carbon modification will be different, correct? Let's look here at the number of protons inside the nucleus, number of neutrons, number of electrons outside the nucleus. So this is inside nucleus, correct? And this is outside. Now, if I will tell you that carbon 12 has carbon 12 atomic mass, it means the mass of electrons are almost 0, correct? The masses. But the number of the protons will be 12. And because it's neutral, so the number of electrons will be 12. Positive 12 charges, negative 12 charges. So that charges are canceling themselves out. Now, since we have neutron, correct? The atomic, look at the atomic mass of carbon. What will be? The atomic mass is 12, but what's the atomic number? Sorry about this. I said 12, that's not 12. That's the atomic mass. The atomic number of carbon, atomic number is 6, correct? Look at this. The top of carbon is 6. The bottom of carbon, how much? 12 point what? 12 point what? 12 point, yes. Atomic mass equal to 12.1. It's gram per mole. So you can tell that the atomic number is equal to number of protons and number of electrons. So we have here atomic number 6, so 6 protons and 6 electrons. And the number of the neutrons will be 12, that's here 12, minus 6 will be 6. So carbon 12 has 6. Since it's 99% present in nature, so we can find it and we can see it, we can touch it, and that's what we call 99% is mostly what brown coal. Brown coal, which that's found in nature, in mining. So people are mining brown coal, and that's carbon 12. That's 99% abundant in nature. The majority of carbon found is 99. Now, brown coal can be used as longer time, but it's not being quitted from that for the instead of crude oil, they are burning brown coal to get electricity out of it. But because it has a lot of smog, a lot of non-burned combustion, that can cause a lot of type of cancer. So most of the countries in the world, they stopped using brown coal as a source of energy. Correct? It's the same situation like crude oil, has a lot of environmental hazards. Gases will come out of the cracking. The same thing with brown coal. A lot of soot, a lot of stuff is not burned very well, so it come out as small tiny nanoparticles in the air, causing a lot of type of cancers. So that's the numbers here. Now 13, the protons here, 13, number of the protons, the positive, they don't change. This is 6, so 6. Number of electrons, they don't change. 6, 6 does not change. Number of positive charges, proton, equals the number of negative charges in a neutral atom. However, the number of neutrons is 13 minus 6, the protons, correct? So atomic mass is the number of proton plus number of neutrons. So you get, this one will be 7. So this one will be 7, this one will be 6. So, and this one will be the same thing. Nothing changed, 6. Electron 6. That's atomic number. Atomic mass of neutron will be 14 minus 6 is 8. So now we have, you can see, we can define now the isotope is isotope if the elements are different modification found in nature due to the different number of neutrons for each modification. Isotopes are modifications of the same element found in nature. They have to be found in nature. If they are not found in nature, we cannot just estimate them. We cannot. They are found in nature with different modification that they have different number of, equal number of protons, equal number of electrons, but they have what the distinct characteristic is, the number of neutrons is different for each modification. Are you following me here? So 6 for 12, isotope 12 have 6, isotope 13 is 7, isotope 14 is 8. And we said 12 is a brown coal, that's used for the energy. In some countries they're still using it. With all due respect to China and India, they do use still brown coal And that's sometimes, if you look at India and China, in sunny day, you cannot see your street in front of you. It's so the smog of this brown coal burning gives you a lot of clouds and you can barely see anything. So the visibility will be almost -0, not zero, below zero. So you can't see nothing, like you are in the middle of the day. Everything looks like in the middle of the night because it's not burning 100%. So it's bringing you a lot of smog, a lot of soot. That's brown coal at 612. This C14, the C12, C14, where we can use C14, although it's a small tiny amount, but it has a very good usage. What's the usage of C14? It turns out this isotope is determining for a long time. Until now, it's being used to determine the dating, the date of old corpse, dead bodies. So if you are working in forensics and there is a dead body and you wanna see how many days this dead body staying in this spot for how many days this person was killed or whatever was dead, then you turn it in the equipment NMR 14, and the C14 is a very good isotope that's used for dating. So if we have a bone, we don't have. If you have a bone of dinosaur, you can take a sample DNA of it and then run the carbon-14 dating on it, and you can determine its age. But in general, that's used in forensics. C14 used in forensics a lot. C13 is used for analytical to determine what you are dealing with. Suppose especially it's used for forensics as well as a normal pharmacy industry. So I want to determine what type of compound, what type of medicine I'm dealing with. So I run carbon-13 for it. That will give me detailed analysis of what I have of medicine I'm dealing with. So carbon-13 for analysis of chemicals, of matters, and carbon-14 for dating, aging, and the 12 is for energy. I mean, still used in India and in China, but Europe is banning it. United States had banned burning brown coal. It's just the side effect of it is tremendous. I mean, it's affecting all type of cancer, especially lung cancer, the first one, but it can cause other cancer when inhaled and then goes to the body system. So those are the isotopes. What's different, the element, those isotopes is number of what? Neutrons. The protons and electrons, they don't change. Protons are inside the nucleus, electrons are spinning around outside, around the nucleus, and the electrostatic interaction is between positive protons and negative electrons. So, any question about this? Any question? That's just a carbon. Now, some elements, such as mercury, they have 7 isotopes. Some calcium has more, maybe 8. Some of them, they have 12 isotopes, depending on their abundance. And the number will be always recorded, the atomic mass, always related to the highest abundance. This one is 99% abundant, correct? So you can see in the periodic table, the atomic mass has to start with what? 12 point something. So the isotope always on the periodic, the most abundant will be given, will take over the molar mass posted on the periodic table. So this is just a chemistry, which is very good to learn. So now, type of question like this, I will give you the element, I'll give you its atomic mass, I will give you the atomic number, and then I will give you, out of this, the number of neutrons on mercury, whatever the mercury isotope is, and then you can just calculate atomic mass is always the sum of protons and neutrons. I gave you the atomic mass, so atomic number is the number of protons. Atomic mass is the sum of both neutrons and protons. Subtract both. Atomic mass minus atomic number will give you number of neutrons. And then give you the number, I'll give you numbers A, B, C, D, whatever, 10, 13, 14, 16. And the correct multiple choice will be within those 4 numbers. Okay, guys, so let's see here. We can take this one here up more. Okay, so well, this is more or less chemistry. There are 2 types of bonding. We have covalent and ionic. The difference between them. Somebody will tell me what is the difference between them. What's the difference between those 2 here? Everybody has taken chemistry in high school? Everybody? No? You should. No? You have. You should. You should. Don't tell me you did not take. So what's the difference between covalent and ionic? I know it's not a chemistry, but that's in the book. So what's the difference between ionic and covalent? It's easy. Ionic. Okay.
No, I remember some of this part. Only isn't ionic cause like together?
No, there's a very distinct feature between them. That's correct, but very distinct one. That's correct. She has still fresh memory about the high school chemistry. That's good, excellent. But there is a distinct one, guys. Don't let me down. Thank you very much. So what's the so guys, look. If I have a metal, so the periodic table is over 70% metals, very few non-metals. So this side here, the right side, is non-metals. And the metals are, all of it here, you can see, all the left side and the bottom side are metals, correct? If I have a metal in a bonding, has to be ionic. The covalent has no metals. You cannot have a covalent bonding that has metals. So here it is, and that's what she said about the transferring of those electrons. That's perfect. That's what's happened. So this is no metal at all. No metals. No metal or metals at all. So you can't have covalent with the metal. Here you have to have metals in these chemicals. So that's the difference. Then the second different one, that's what she's stated, that's correct. You have a transfer of electrons. Ionic compound always is dealing with transfer of electrons. Those electrons are found in the outermost shell called valence electrons. Valence electrons. You don't have to do details, but at least the outermost, the last orbital found those electrons. They are called valence electrons. They transfer. If you have ionic bonding, they transfer. But covalent, they don't. They share. That's what you said, correct? They share. Sharing. That's an A here. Sharing the electrons, valence electrons. So that's the 2 distinct features of differences between the 2 bonding, the 2 types of bonding. Ionic, you deal with metals. Non-ionic or covalent, they don't deal with metals. They are dealing with what? Non-metals. Non-metals. And non-metals are very few, maybe 25 You have 75 to 25 something. 75 is metals, 25 is non-metal or so. So very few, you can count them there in the left side. You can count about 20 maybe, something like this. So very few non-metals, but a lot, majority of metals. So ionic, you have to have a metal, and this metal has the ability to share, to transfer its valence electrons. It's electron donors. And the non-metal inside the ionic bond will be electrons acceptor. Covalent, there is no transfer of electrons at all. They are sharing their what? Their valence electron, their electrons, they are sharing. So, and here you can see all those type of molecules, and become ionic molecule here. Do we have ionic molecule here? Ionic. Do you have any ionic molecule here? Yes or no? Somebody said no. Second, you are second. I'm third. I'm making first, second, and third. There's none there. Why? Do you have any metal there? No. So all those are what? Covalent. All those molecules are covalent, not ionic. That's totally different. That's all covalent. There's no metal there. So those are covalent. Perfect. So the concept is there. So now let's define acid and bases. Somebody will define acid and bases without looking at this definition. What's an acid? Now you are in your kitchen and you want to have some chemicals or whatever, and you want to test it if it's really acidic or basic. What you will do? In the kitchen, your kitchen. But how you test it? How you test that? To see. What's that? You cannot take concentrated or vinegar to your face. That's about 5%. But yeah, you can try it, but try it on your skin. That's great, correct? So you take with the small tiny amount with your finger or a tissue, immerse it to this kitchen, whatever the chemical in the kitchen, and then put it in your skin. If it stings, that's what? That's an acid. All the bees, all the ants, mostly insects, they when they attack you with acid. Yes, all of them. The simple ones is not really killing. Those are ants, formic acid. That's non-toxic, not lethal, not killing. But if you have a killing bees, for example, they will give you a real acid, very concentrated acid, and a real lethal acid or lethal other compounds beside the acids. But all the stinging stuff is coming from acid. The ants, they use formic acid. Formic acid, correct? So, but if that's different from the poison from snake. Snake have no acid or base. As they are using a real organic poison, based on nitrogen. Most of the time, they have poison with nitrogen based. So that's different. But ants, for example, they will sting you, and some normal bees will sting you. They use formic acid. You get swollen in the skin, burning a little bit, and then if you put some ice pack on it or you just cool it down, it will disappear later on. So, but yeah, that's what's the acids. Acid stings. How about the base? So I put it on my skin, something stings. I said this is an acid. The problem with those acid and bases at home, they are colorless. They don't smell except maybe vinegar. That's acetic acid, correct? Vinegar, you can't smell it. But how about the other acids inside your house, inside your kitchen? And the bases, they look alike, colorless. They look like fresh tap water. But how I can determine this? I have a base in my kitchen. Somebody will tell me? In the kitchen, how we can. So now I have small tiny stuff, put it my skin stink, as I said, this is an acid. How about I put it my skin and start rubbing my skin? It's very slippery. Anything slippery, soapy, slippery, that's a base. Anything in your kitchen, any chemicals in your kitchen, especially those detergent and soaps, anything slippery has to be a base. Are you following me here? That's the difference. Easy. You don't have to take the pH and measure the pH. We'll learn what the pH is. So the general definition, the acids, those acids, they can dissociate, give you protons. The protons does not exist. This one is not there, but the definition, does not exist. You have proton here plus H2O. That really exists, called hydronium ion. So this is called hydronium ion. That really exists in this hydronium ion. And this is called proton ion. Now, proton ion do not exist in real life, because as soon as they produce, they are reacting with H2O to produce hydronium. This is stable. This can be seen, can be detected, can be measured. We don't measure really this because it's not there inside the solution. But anyway, so the acid, they have this ability of this hydronium ion producing, and they can donate. See, they're like the ionic compound, the metals are donating their electrons, and in the ionic compound, the nonmetals are accepting those donations from the metals. Here, the acids are the compounds that can donate the hydronium ion, correct? And the bases, they are the ones that are accepting this hydronium ion, correct? Same as the opposite, like what we have in the ionic compound. So metals in ionic compound, they are donating electrons, and the bases are compounds that's accepting electrons. Here we have bases accepting hydronium, and acids are donating hydronium ion. That's the correct modern definition. So he has an old Arrhenius definition. So his definition is very old. That's Arrhenius type of definition. Not all compounds that has OH, that does not have OH or does have OH bases. We have compounds that have OH, but they are not basic, not basic and not acidic. So here it is, and that's really not always true. Not always true. So the definition I give you this, so therefore I'm not giving you because the definition is obsolete. It's very old. So that's an acid. That's acid as donor for this hydronium ion, and the bases are acceptor of this hydronium ion. Now with the OH business here, that's not always true. What can somebody will tell me what this compound is? Don't tell me you don't know it. Everybody should know this. So what is this compound is? Somebody? Any? You have taken that in high school. A long time ago? Okay. Well, that's everybody drinks, correct? No, that's not. No. Okay, she is going through all the list. That's alcohol. No comments. Kein Kommentar. So anyway, so that's ethanol. Ethanol does have OH. You tell me does have OH is a basic? No. Ethanol is not basic. You will not drink it if it's basic, correct? It will be bitter. It will be very, very bitter. You cannot drink it now. So ethanol has a very nice smell, colorless, like fresh tap water looks colorless, very distinct color, very light like H2O. It's bigger than H2O. H2O is different. H2O is H2O. It's said here. H2O, that's the tap water. So that's different from you have two carbons. Here H2O does not have any carbon at all. So what you say about the OH? So the business of OH in the book, that's I can tell me. I have an impression about the author has a little bit limited knowledge of chemistry because he is using about 120-year-old definition of Arrhenius. Yeah, that's not recent. That's not recent definition. Not OH is not every compound or any chemical or any drug or any medicine does have OH means it's a basic or acidic. That can't be. There are many compounds, they have OH, but they are not basic, not acidic. They are just neutral. They are not neutral. You put them inside the pH litmus paper, they come neutral. No color change, nothing. They are neutral. So, and that's the definition is limited. That's definition in the case if you have ionic compound. If you have ionic compound that has OH, that's basic. Correct? If you have covalent that has H or hydronium ion, that's maybe acidic. But that's, as I said, very, very old, over 100 year, I think, definition of Arrhenius. It's way obsolete, so nobody is using it. We are using Brosted and Lowry and Lewis definitions, which is very not far away, 50, 60 years or less than that. So those are very modern type of definition, which is really correct. Because some people looked at some alcohols, they have OH, so what in the world they have OH? You said them basic? And that's what I have proven one day for my students. Said, well, you give them pH litmus paper and they tested, nothing there. It came out neutral. I said, well, not every compound has OH, it means basic. And not all compounds, they have H on it, they are acidic. So it has to do always with, as she said, it has always with transfer, whether electrons or hydronium ion. Those are transferring concept is very important to determine the whole thing. So what the pH? Somebody will tell me what the pH is? What's the pH? What's the pH came from two alphabets, P and H, correct? So P and H, well, it turns out the P is meaning minus log. That's math. So P. Anytime I write in engineering and sciences, P means minus log. And the H is the concentration of H plus. And this is not existent. We have to put the hydronium ion. Minus log the concentration of H3O plus. So anytime, for example, my name, I put P Ataya, so P and then my name here. So then translated in science, that's minus log Ataya. Are you following me here? So if you write P in front of anything, it means always remember that's minus log. Anytime, whether a name, alphabet, anytime I put P in front of anything, you can, in your mind, P means what? P means minus log, abbreviation. Instead of writing all this minus log, abbreviated in science and engineering with the small letter P. Okay, so minus log of the concentration of H3O plus. So this is an acid. So the pH is a measuring tool for the acidity and basicity of a solution. So what is the pH? Is a measuring tool. Is a tool, a scale. Is a tool to measure the acidity and the basicity of a solution, in aqueous solution. In organic solution, that's totally different. You have you have another type of scale. Another type, not the pH. They have Hammett equation scale, so you don't have that scale there. So, but anyway, but if you look, that's the pH. So now, depending on the pH, it has a scale. Then let's look at the scale here. Here, just give you the idea when is the solution is acid, where is basic, but we can't say that here it is. Can I take this one out? So here it is the pH scale here. By the way, this chapter is overlapped because the same thing I'm teaching you in chemistry, this is the same in physics. So physics and chemistry is very close together. So most of the time, physics is very close to chemistry in this type of those chapters here. So the pH scale. So we have 3 scales. So the pH scale from 0 to 6.4. Now I'm giving you what? I'm giving you a fractional pH. So you know why. Then greater than 6.4, greater than 6.4 to 7.4. Then greater than 7.4 to 14. So here, this is basic. This is neutral. This is acidic. Why I'm putting 6.4, not the whole number? Because now we have, in the past they gave you whole number because technology was not there. Now the technology, they had produced the digital pH meter, which give you 3 digits or 4 digits of the pH. Are you following me here? So therefore 6.4, you stop there. So if I have pH, what's the pH here? Tell me what's the pH here is. What's the pH is? Acidic, basic, or neutral? What's the pH here? Yeah. It's what? Correct. Correct. In the past, textbook were teaching us 7.0. But now the technology is there and they have a pH, digital ones. They can go to 4 or 5 digits, 4 significant figures. So what you will do here, you have to stop here. Ask yourself, this is 9. So this value is 7.5. And this really is around 8. Correct? That has to be what? Greater than 7. That has to be basic. So that has to be what? This one here. That's basic. So that's the reason the new scale is different from the old scale here. The old scale technology was not there. There's no pH, digital pH meter. Now we have pH meter, can't have allowed 5, 6 significant figures. And therefore, it has to be at least 2 digits. You have to get 2 significant figures of that, 7.4. Greater than 7.4, then it will go to the next scale. So, and the highest numbers, here's the lowest number. This is the highly acidic. 0, highly acidic. Correct? 0 here. 14 here, highly basic. That's what we have to know about this. So that's the scale. We can determine, that's an aqueous solution. That has H2O is there. But if you are dealing with organic stuff, organic solution, that's totally different. The scale starts from 50, 60, 70, 80, 100, in hundreds. Start 50, pH of 50, pH of 60. That's not this, the aqueous. Aqueous go from 0 to 14. But the non-aqueous, the organic, goes higher than this, up to hundreds. So, any question about this? Any question? So that's a review for high school chemistry, correct? You covered that, I think, but it's gone with the wind, I guess, or gone with the sun, whatever. So, yeah, I'm just kidding. I'm just kidding. So, but that's sometimes. So here it is. So, but I said the book is lacking new definitions. But the pH is okay, but did not show that we have now advances technology that pH digital meters, they can, the whole thing. Can somebody tell me how to have, in your kitchen, how you can make a litmus paper in your kitchen? Somebody will tell me? You can make it yourself. No? You have YouTube, correct? I was looking at that other day. Somebody, he has an old airplane, real old, but junky, from junkyard. I don't know how he got that airplane. It's a military one, it's an old one, in the World War whatever, II or whatever. So he wants to see if he can use YouTube to let the engine running at least. I mean, the engine is over 50, 70 years old, so it's already rusted. But he wants to learn about all the techniques and how in the world he will get a YouTube video. Goes back 70 years. At that time, there is no videos at all. But anyway, in the sense, if you want to do, you can do it now with the YouTube. You can make your litmus paper by yourself. From what? Red cabbage. We did it, this one here in the lab. I did it for my students. They like it, and they did it. And they took it with them at home, so they keep it. I told them to buy the big coffee filters, and then we immerse this solution, red cabbage, inside this, and let it dry, air dry, no oven dry, because you evaporate then the whole solution. And this will be universal because it goes from this red cabbage immersed or soaked into the coffee filter. It has the ability to test the pH, and we did from 0 to 14. I mean, red cabbage will not cost you that much, less than, the head is less than $1. And then just boil it in tap water for half an hour. Take it out, extract all the leaves, take that out, take the solution, concentrated solution, add in it rubbing alcohol. Why are we adding rubbing alcohol? There's no reaction. Rubbing alcohol to kill what? Bacteria, because the bacteria is getting crazy when it smells what? Red cabbage. Red cabbage in few minutes will be what? Smelling very bad. Why? Because the bacteria loves the smell of red cabbage and they start eating it and start what? Start be rotten and smells very bad. So if you have red cabbage solution and you don't put any killing compounds for this bacteria, the red cabbage will in few minutes will be gone. Will be smelling very bad. So what we do rubbing alcohol inside, and then keep it cool down, rubbing alcohol inside. Then after a couple of minutes, we soak the whole coffee filter with it, with this solution, keep it dry until next day. And then you can cut it in small pieces and dump it in any food you have, in any solution you have at home, in the kitchen. You have litmus paper almost for not that much. Because rubbing alcohol you have, if you have a kitchen, you have to have rubbing alcohol inside that kitchen. Why? Why you have to have rubbing alcohol inside the kitchen? Somebody will tell me? What's that? Clean one. Come on, guys, don't let me down. We have to have two of them, hydrogen peroxide and rubbing alcohol. No? Correct, thank you, here we are. That's an antiseptic. Rubbing alcohol is antiseptic. So if you have a wound by the knife, so the bacteria will not come and feed on your blood and putting all the stuff in your bloodstream. So antiseptic, the best antiseptic at home is rubbing alcohol, or hydrogen peroxide. So they really antibacterial infection. So that's the good thing about both of them. You have to have either or. I have both because me and my wife sometimes we cut salad or something, we cut our fingers or something. So then we have something to recover from. So you have to have it. You have to have. If you have a kitchen, you are missing something from. You have to have, and those are sold in pharmacy, Walmart. All these pharmacies are selling it with different concentration. The best rubbing alcohol will be 90 and above, but they have 70 is good. They have 65 something, 60 that's good, 80 good, but the best thing 90 and above that will be highly concentrated rubbing alcohol. Anyway, so any questions so far? So what is the pH? The pH is a measuring tool to measure the acidity and basicity of a solution. And I gave you the range because we have now technical advances. We have pH digital. The old days we did not have those digital pH meters. So, and I think let me look at. We covered most of stuff of 2, I think. Type of kinetic. What chapter is this? This chapter 2 or chapter 3?
This is
chapter 2. Okay. Well, I think that's the scale here, so you can see the pH. Now, if you have done your litmus paper your own with this red cabbage solution, don't forget to put rubbing alcohol inside. Otherwise, the bacteria will come. They love it. They really love it. I did it in the experiment. Showed the students if you're missing the rubbing alcohol, within few minutes, the whole solution or the extract of this red cabbage smells very, very bad. So the bacteria came in and then attacked the whole thing, and they're enjoying, they're inside maybe dancing and drinking it and whatever they are doing with the solution of the extract of this red cabbage. As soon as you put rubbing alcohol, guess what? I have a solution still there for almost 4 years in the fridge, in the lab. 4 years still there. Whenever we need it, we just soak in some filter paper and then use it as a litmus paper and dry them. But because we have isopropyl alcohol or rubbing alcohol, bacteria will not dare even to come. They will kill them. That's the reason we have it in the kitchen. Antiseptic, it kills all the bacteria. So here you can test your coffee, your tea, your hamburger, whatever food you want. You can test it. Your gasoline, whatever you want, you can see. You can measure the pH of this food or this item you want. And you can test the pH, whether acidic, basic, or neutral. That's for extra information. You don't have to do it, but at least you'll have the idea. So most of the detergents are whether acidic or basics. Like Drano is sodium hydroxide, it's basic, concentrate basic. And some of the top detergent is acidic, hydrochloric acid, concentrated. Windex is a basic, ammonium hydroxide. Windex, cleaning the glasses, glass windows. And you can see most of the stuff at your kitchen is whether basic, acidic, or neutral. But some organic stuff like alcohol, they are not acid, not base. They'll just give you neutral, so neutral scale. That's not acidic or basic. Well, organic compound have a carbon back. What is difference between organic and inorganic? Now, refreshment of high school chemistry. What's the difference between organic and inorganic chemistry? And we have some science connected to biology. Don't think chemistry by itself. Because did you hear about biochemistry? That's a science between both biology and chemistry. And you have physical chemistry. That's physics and chemistry. So chemistry is in between. So in between sciences. So, what's the difference between organic and inorganic chemicals? If I have a chemical, can I say this is organic or this is um, inorganic? Can I say? Yes, I can. How? Yes. The inorganic? No, that's not all. Unfortunately, those are drug-related stuff. Drug-related stuff, marijuana, hashish, opium, methamphetamine, LCD, and all the list you can go. They have nitrogen base, and those are basic. Those are basic. And if you take too much of them, you introduce the blood very highly basic solutions. So they have nitrogen. Anytime I have a nitrogen, I can expect this compound will be what? Will be basic. So organic compound, not per se, they can be acidic or basic. Some of them, vinegar is organic, correct? But acidic. So, but what's make a distinction between organic and inorganic? Just per se. I will say this one here is H2O. It is H2O. Oops, sorry, H2O here versus methanol. What's the distinction between them? Look, I give you the answer. This is said to be inorganic. This is inorganic, correct? However, this is organic here. What makes the distinction between them? Sorry. You can tell from the answer from the structures. What's missing? What's missing in one? What is there? Correct. See the difference? Perfect. Therefore, we call organic chemistry is a chemistry of carbon. Yes, thank you. Now whatever is in the background of the brain is coming now. It's coming. Whatever in the background of the brain is coming up front. Correct? That's good. Excellent. So that's the difference here is this one here. That's the key. That's the answer. See, that's inorganic. We said we don't have metal. If we have metal, then we'll be ionic, inorganic, but ionic. But this is covalent. Both of them are covalent. However, one has carbon, one does have no carbon. Correct? Are you following me here? So the organic compound or chemicals or drugs or it's a must. Carbon and hydrogen is a must. Then they can have oxygen. Oxygen is just it's just an addition. So a bonus. Oxygen is a bonus. Can be nitrogen, correct? Can be any other. Can be sulfur. I have the same compound. This can be sulfur here. See? Can be even nitrogen. Here it is. NH2. That's nitrogen here. N. That's amine. The other one is mercaptan. Thiosulfate. Methane, thiosulfide. So you can look at all those here. But the main thing is not the bonus element here. Those are bonuses. They can change. But carbon and hydrogen is a must. Carbon and hydrogen is a must. And carbon is absolutely must, and therefore organic chemistry, organic chemicals are said to be, or organic chemistry is carbon chemistry. Chemistry of what? Of carbon. Correct? So that's the difference here between those. So now the idea here of the give you 4 major organic compounds. Can I take this one out? Can I take this one out? Okay, let's take this one out. And he puts for you, the authors put for you bioorganic compounds. Those are going inside our bodies and they have different functions. Correct? So that's the idea where chemistry and biology is running hand to hand in a science called biochemistry. Biochemistry. So compound is a chemicals, but its effect inside the body is biology. Correct? So lipids are compounds that are not soluble. You can sum all those compounds that are not soluble in H2O called lipids. Any compound that's not soluble in H2O called lipids. Carbohydrates. Somebody will tell me what carbohydrates are. You eat them, correct? When you eat the fat nutrition give you carbohydrate, correct? What is carbohydrate? Somebody will tell me what carbohydrate is? And I will let you go. Give me just an answer for this. What's that carbohydrate? Somebody will tell me? Carbohydrate. What's that? Somebody will tell me? Yes, that's sugar. Now, did you Google that? I was watching somebody is Googling around, correct? No comments. Okay, she was Googling that, but it's okay. Don't feel ashamed, that's fine, that's happen. This can happen. Anyway, but I was very concentrated on your keyboard here. So that's Googling for me, or Yahooing, or Binging, whatever you call it. So carbohydrates is a is ketones or aldehyde with hydroxide groups. So you have ketones or aldehydes with a lot of OH groups. So they are not basic and not acidic. They are neutral, correct? So they are neutral with a lot of, for example, glucose, which is, I will quit here. This is glucose, guys. Looks like it is all this OH, H, OH, H, OH, H, 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 and then H, CH2OH. So that's a glucose here, correct? It's a cyclic ring. That's a glucose. C6H12O6. I might just run it very quick, but that's the C6H12O6. So those are coming from the aldehyde. Those are aldehyde when they're not ring. Those aldehyde or ketones with a lot of OHs. So don't come to the idea because they are OHs. They are what? They are basic. They are not basic, they are not acidic, they are neutral. Okay, guys, I'll stop here. Correct? I'll see you this Wednesday. I hope I can put the whole exam together, which is just 25. 25, so 25, and then we have 15 chapters. Maybe each chapter will have one question, and then 15, and then, or two. Two will be 30. You like 30? I'll put 30. I like this. Okay, yes. How much they are? Well, there are plenty of them. I can't count them. You can't count them yourself. So there are plenty of them there. Yes. Okay, I'll stop here, guys.